Okay, so I just rerun the same pre-comp I had, but I just like put a deep pre-color on the smoke to have something a bit more, something a bit darker, that would kind of blend in more with the rest. So I think in terms of smoke simulations, we're good. So the other thing I wanted to add as well is to sell a bit more the impact, because for now we have like few frames where nothing's really happening. So what I wanted to do is like add a kind of like a ring shockwave, something that would go from the point of impact towards the camera and towards the exterior. So like to have something a bit on the side as well. I think that can help. So like let's start to work on that, and then like finally we'll do the electrical arcs. So let's go. Okay, cool. So I'm going to create like a new geometry. I'm going to call it shockwave. Alright, so we can dive inside, and I'm going to create a circle. Let's switch to auto update, and we're going to switch the plane Z-Dex, so like it's flat on the ground. Let's check a bit the rest. Alright, so now it's over there, and basically, so we want something to happen around frame 10:35, so around here, right? So we're going to move the circle at the spot of the impact. Alright, so it's nice and centered, and I'm going to create a transform. I'm going to change the pivots with an expression $CEX, CEY, CEZ. That way you can see now that the pivot is centered, and now we can basically play with the scale and do our timing that way. What I will do first is I'm going to create a polyframe, and I'm going to make this circle a polygon with a bit more subdivision, like say 30, 32. So now we can see basically we have those points. The polyframe here is going to create some normals. And I'm going to change the style to is it primitive centroid? Yeah, points. Alright, cool. So like you need to untick normal and put n in the tangent name. Now you have this. That's cool. So I'm going to put a carve node. It's just going to basically you know, like kind of remove the primitive and only keep like a polyline. That's what we want. And also, yeah, we're going to reverse the normal attributes, because for now it's pushing inward. We want something pushing outwards. So we're going to say n equals minus n. Reverse normal. That's cool. Over there. Alright. So like at frame 10:34, we can say that we are at 0. At then 10:39, we have like we're at I don't know yet, 10, 20. We need to shift click to have the animation editor, and I'm going to switch the interpolation to linear. Alright, so let's have a look at the timing. So let's make a flipbook. So that way we'll also have something a bit before that would kind of, yeah, it will help the transition between the two effects. So that's cool. So now we have the timing. And the other thing is now we're going to compute the velocity. Compute velocity, alright. And oh yeah, before we animate, so where it's not time dependent, I'm going to scatter a bunch of points and I'm going to give them an ID. So I'm going to type I at ID, I is for integer, equals pt num. It's like the point number. Let's call this ID. So now basically those guys, they have a normal, but they also do have a velocity. Cool, and now let's trail those guys. We can put an add. Before the geometry, but keep the point. And now if we put like another add, but this time we group them by ID, bam, we have those lines, which is cool. And so basically by increasing the trail length, we'll source for longer. Basically the lines will be longer that way. Alright, so we can stay at 3, should be alright. And now basically we're going to create a wrangle called density equals density times, and we're going to maybe put like a float for the animation, because maybe we want to source a bit less density, maybe something that we can keyframe. For now I'm just going to put those two at 1. Density, alright. And thing is, okay, like now if I just rasterize, I think we've kind of done this before, but if I rasterize and I put like a decent particle scale, basically the problem that we have is that we have some gaps. And that totally makes sense, because if you have to look at the points, basically we have points here, points here, points here. So like we're only sourcing density where the points are. So that's why I like to do this technique with a small resample. Now we have points everywhere, and basically, bam, now we have some stuff that's pretty good looking. So we're also going to put V. I'm just going to so yeah, you know, like as soon as you put like the V, it kind of get visualized, so it looks a bit ugly. So what you can do here is you can do V volume, adjust the visualization, and put it to invisible. That way you don't have to see that thing. Yeah, that's cool. Bit of velocity blur maybe. Nah, should be good. Alright, so we have some stuff, basically, it's working. Cool thing about the trails was that it will Yeah, now we need to make sure that we don't source when we don't have any length. So now if I do light geometry, keep the points. I'm just going to remove. I'm going to put like before the resample and before the density as well. Just after the add, actually, I'm just going to put the measures up. I'm going to put it in parameter, and I'm going to do split. I'm going to do parameter greater than 0.2. So that way we only keep, you know, this kind of stuff, and then it gets removed. Cool. You can hide those things as well. Right. So then, like, we don't have any points left, so we're not like sourcing. Otherwise, we'll be sourcing from the side all the whole frame range. That's not what we want. We want just something that kind of stop to source anything. Cool. I'm going to put the density after the resample and even after the add. Basically, why do I do this? It's just like I just remove the primitive. That's not something super important, but I think it's just like sometimes it's easier to visualize what you're actually giving to the solver in terms of resolution stuff. You can see, for example, here it's a bit like the overall sphere, the overall circle is a bit low res. You can see like the kind of hard edges. So I would maybe increase it to 64 to have something a bit more smooth. But yeah, all right. So that's that, and then. Alright, so this is like the source. Timing is good. And now we can create dot network again. We're going to create a pyro solver sparse one, smoke object, sparse one as well, and volume source. And we're going to put it in the third one. We're going to put first context geometry, initialize a source smoke. We can remove the temperature, V equals val. Yeah. Alright, and then we're just going to keyframe those two. Not keyframe, but just like link those two. Sorry about this. So you're going to call it smoke sim. Top import fields. Top network is this. Top node is this. Preset smoke, and we're going to delete everything but the density and the val. No. Alright. So we have something. Something is happening. Not much. It's a bit weird, but something is definitely happening. We can remove our on light to the viewport so that it doesn't get too burned out. And so what is actually happening over there? Oh yeah, we're actually going to also put enlarge fields to contain the source. Alright, so now we're that way we make sure that the container is at least as big as the source. So now we can see the stuff. Yeah, it's doing alright. So the first thing that we want to do is, like, of course, to reduce the the velocity, I like to just put it to 0.1 and still add. I feel it's working pretty well with the 24 frames a second time increment. I'm going to create a new field. I'm going to type density, and I'm going to, in the source volume and the target volume, I'm going to just add in the divergence. All right. So source density. So it's working. The thing is, it's like the most obvious is anticipating way too fast. So we can even like try it at 0.1. We can try also to reduce a bit the voxel size, so we have a bit more definition as well. So that's cool. But the thing also is that we want something that is getting a bit more integrated with the environment. And I feel like you can see it's really flat. So I think what would be good would be to have first the collision with the environment, and also yeah, basically the collision in the environment, and basically sourcing only on the where there is environment. So like we're going to ray everything on the environment. So for example, this spot is going to be on the sidewalk and not like totally inside. Yeah. So how do we do that? We're just going to look up for the sidewalk object merge over there. Okay, sidewalk. Same for the road. I'm going to merge those two together. And basically at the resample phase, so over there, just going to ray everything to minimum distance. What about if we do it a bit before? That'd be working better. And oh yeah, and also we're going to just remove all the facing pointing downwards. So down faces. We're going to select those by normal. So everything that is kind of aligned to the -1 vector is going to be in this group. And then we're going to remove it down faces. Alright, so now it's removed. And basically we have like less, we should have less interfact. Alright, so now it's getting a bit more integrated with the environment. But I feel we can even put another ray on it. Yeah. That way, like, that makes already like a pretty big difference. because the reason why we're doing it in 3D and not in 2D is because like we want, to have like the best interaction with the environment. So like that makes total sense to spend a bit more time, but like to make sure that everything is properly feels more in the real world, in real 3D space. Alright, so that's cool. And the last thing, so we're just going to also copy and paste, or we can just like recreate one. It's not that big of a deal. In colliders, and we're going to object merge this on colliders, and we're going to create our collision source. Remember this one. On one side we'll have the geometry, and on the other we'll have geo, and on the other the VDB. That way we'll be able to put a bit of gravity. For now we're just going to put it -1 static object. We're going to merge it. And on the shockwave of geo into the subpath and collision, the proxy volume of VDB, volume sample. Let's double check that we have everything working. Collision guides, display geometry, and alright, it's looking good enough. Cool, and now let's have a look. Do a flip book. Okay, so we have some weird mushroom under the ground, but that doesn't, like, that's not a really big deal. Boom, bam, alright, cool. This may be a bit spading a bit too fast still, and now we're going to put some micro solver as well. The gas disturb in the advection, and I'm going to put like a few gas disturb actually. Oh, sorry, for now it's dissipate, but what's actually the disturb? So we're like at 1075, 0.05. So we're going to go to block base, and the side will be 0.2 is good. And then we're going to put like another one on 0.6. Try to still reduce that a bit, and yeah, so this is good. Let's see how this look. It's a bit uniform, so what we can do is we can create a volume VOP. And we're going to multiply the density by a noise to have like a more interesting source. Going to clamp it as well. That was more interesting. Alright, cool. And what else? Just going to hide the stuff we had on the viewports. Like this as well. Cool. We're still dissipating a bit fast, so I'm going to try to reduce it to 0.05. Should be good. For now, let's remove the divergence, and we're just going to source a bit more density. Alright, let's try it out. Alright, kind of like it. Bam! Alright. Yeah, that would definitely help to integrate everything. That would be like pretty low density volume as well. So like that's like we don't need to spend like hours and hours to do like the perfect sim. Maybe it's going a bit too much upward. I kind of like this, the fact that the smoke is going upward. But like maybe by putting a bit more gravity, it will go up and then like fall down as well. And that's something that we can try. Bam. Alright, let's try it out. Also maybe like on the noise, maybe we can make it a bit more low frequency. To almost have like kind of patches of stuff. Less uniform. Can try to put -2. Shockwave. Okay, yeah, I kind of like this one better because like we have a bit more empty patches in the foreground, so I feel that's cool. We still have some smoke going up, but it's like a bit less. You can see it's like, yeah, the pattern as well from the disturbance. Yeah, not looking cool. And then like we'll have also like the stone also, so we could have been like really 100 physically based and actually put the road in the collision of this, but like that might be a bit overkill, so I'm not going to do it. And you can if you want to. like to sell the impact, I feel like that's a good extra layer to add. So yeah, should be all right. I'm just going to test something as well. Usually, for example, like especially on those kind of camera where you're actually seeing only one side of basically we don't really need to simulate more on the other side. So what we can do here is we can say we can remove it along the z-axis. So if I do remove by z, p dot z smaller than the threshold. Oh, all right. I'm going to do remove point 0 pt num, and then we can play with that. I was actually not seeing this node. I feel like 0 is alright. Like we don't need much after that, so maybe we can give it an extra hint. But yeah, like you can see here, we're kind of like saving a lot of space, and especially with this camera angle, we won't see much of a difference. Maybe it's a bit too much, so we can give it a few more meters, but that way we will still like be saving up some voxels, so that's a good stuff, like a good idea to do. So let's put a pyro post process after like we import the fields, and we're going to as always convert to VDB, resample the val, and use 16 bits float. And now I'm just going to copy and paste one of the file cache I had for the smoke, and this one I'm going to call it shockwave smoke simulation. And then voila, we're good. Let's press save to disk. Alright, nice. Now we have our shockwave, so we're just going to get a null and call it out. Nice. And same thing, we're going to create a layer. I'm just going to duplicate the smoke gradder. I'm going to call it shockwave smoke RDR. I'm going to drag and drop the shockwave. I'm going to create another layer here. Call it shockwave. I'm going to drag and drop this. We can also create a fetch. Get one of the fetches, and yeah, in shockwave, same thing. Going to drag and drop this. Can put it inside the merge. Doesn't have to be connected because this one is not dependent from the other, so we should be good. And yeah, that's about it for this layer. So I guess the last ones are the electric layers. So basically I splitted the electricity in a few different layers. There is like the electricity between the characters and the ground, the electricity just on the character, and also like the electricity, the electrical arcs on the impact going out of the main destruction. So just for now, we're going to start with the character electricity. So do car electricity. So I'm going to create an object merge, and I'm going to look at the animation. So we have our animation. I'm going to create a scatter, alright. We have 1,000 points, alright. See, it is, for now it is packed, so I'm just going to unpack it before. That way now we can see those points, right? So that's cool. I'm going to put something in the seed, $F, so it does change at every frame. It's going to do that by default, but it's more like either way it's going to seed. And I'm just going to make 2 points. Alright, that's cool. And yeah, because so basically what will happen is it will create one arc that connects those 2 points, right? So like those are going to change every frame. So we could definitely try to see how that'll look if we create kind of like an ID. Or like even just for now we can just create an add node and create a polygon. You can see it's like it's doing more or less what you would expect from some electricity effect, right? But we'll go a bit more complex and more interesting than this. So first thing I'm going to do is I'm going to give those points a name. Like I'm just going to call it name. I'm going to create int num equals floor pt num divided by 2 s equals name frame num plus itoa frame plus num plus itoa Cool. So why do I do that? So it's basically it's going to the num is going to floor everything divided by 2. So that means like here we can create like let's create a new parameter like an integer, and we're going to call it arc number. All right. We're going to multiply it here. We're going to put it 2. So like let's say now we have like 4 points, and basically 0.0 and 0.1 are going to be connected, and 0.2 and 0.3 are going to be connected because they have the same num, right? So it's like divided by 2. It's going to floor the numbers. So like 0 divided by 2 equals 0, 1 divided by 2 is going to be 0.5, but floored to the next to the lower integer it's going to be 0 as well. So as they will have the same num, they will connect, and those one as well. And also as we're going to put it in the solver, basically it's going to change every frame. So we want to store this data, so that way we only keep those points. We know that they are sourced at the frame 1038, for example. We want to only make them connected to other points that are connected at the same that are sourced at the same frame. So that's why we do this kind of bit weird stuff. But like basically we're going to create by name, and then we'll be able to here, instead of having some weird stuff, we're just going to create add by attribute and name, and that way that's what we'll have. Cool. So now let's create a pop network. To go inside, and we're going to switch to all points. Alright, so now basically all the electricity is going to accumulate, and you can see it's only going to accumulate with the one they sourced them. They're only going to connect with the same one they were sourced with, so that's cool. What we can do as well, I'm going to do a switch, and I'm going to remove when I don't want to source them. So basically I'll say I'm going to start, if they're like, I'm going to start sourcing at 1018 for example. So I'm going to say in the switch, if $f higher than 1018, you keep to 0, so this stream, otherwise you switch to 1. So that means here you can see before 1018 it was 1, and then it became 0. And that way we'll be able to source only after this point, right? That's cool, and that's what we kind of wanted. I'm going to time shift it as well. And in the scatter, we're going to output some primitive attributes. And now we're going to use the attribute interpolate. So it's going to look up for those attributes, the prim num and the prim uv, and it's going to match the animation basically. You can see that they are keeping the same space on the object. Alright, so yeah, I need to give it to the unpacked version as well. Alright, so that's cool. It is working. Alright, and then last thing would be to we're going to reduce quite a lot the life expectancy to 0.1 and the variance to 0.2 and the variance to 0.1, and we're going to remove any rated velocity you might have. Alright, so now we got like kind of like a charging effect. It's looking already way better. Cool. So I guess now we'll just we'll do some shading, yeah. And to put the resample. Alright, yeah. Also, like one other thing with the attribute interpolate, if we don't have any points, it's going to do like some weird errors. So I'm just going to create here a null. I'm going to call it sample endpoints, and I'm going to create a switch with another null called nothing. And here I'm going to create the spare inputs on the switch. I'm going to drag and drop the sample endpoints here, and I'm just going to create like another small expression. I'm going to say if n points of -1 being the spare input, equals double equals 0, then you're going to go to the left stream, otherwise you can go to the first input. Alright, so like that way, end of the stream, we don't have any errors, which is cool. Alright, so this is what we have. Let's see with the characters how that looks. That looks alright. Yeah, that's cool. Alright, so now we're going to do some shading in. Yeah, let's do some shading. Alright, so now let's try to make those perfect line look like electrical arcs. So basically now, after I put down a resample, we have different primitives with several points. First off, I'm going to increase a bit the amount of points by reducing the length. So it's going to be basically by putting 2005, like the length of each line between each point is going to be this. So that's cool. I'm going to scroll down and activate the curve view attributes. And alright, then I'm going to add some noise to that. Create an attribute VOP. I'm going to noise, call it noise. Oops, I disconnected over there. P to pass, and basically I'm going to add a noise value to the existing position. So over there, over there. Come on, bro. Cool. So that's what we have now. It's already looking way more like electrical arc. So I'm going to right click, create input parameters on this. You know the drill. Sparse convolution noise, and also like in the type we're going to go for a 3D noise because it's looking better. Increase the frequency, reducing the amplitude. Alright, so now yeah, that's pretty cool. That's what we want. And now I'm going to, but the thing is, the problem now, like the end of each arcs are kind of disconnected from the main geometry, so we don't want that. So I'm going to put a bind and call the attribute that we had, curve view. First off, let's try to visualize what the curve view is. If I put a coalesce up and do a ramp, you can see that curve view is actually just like a ramp from 0 to 1. And it's just going to yeah, just to define where are we on each line. And what we want here is basically is that when it's 0, we don't have any noise. When it's 1, we don't have any noise. And then gradually, the more you go in around the middle of the lines, the more noise you want applied. So I'm going to ramp the curve view attribute. and then I'm going to multiply it by the amount of noise. Cool. In the ramp, we can switch it to spline. And basically, we're just going to switch. We're going to put like 100% in 0.5. And we can switch it a bit to Bezier to have something a bit more smooth. Something like this. Alright, so that way we still have the connections, which is pretty important. So alright, cool. Fair enough. And also instead of the position, we're going to use the rest position. So in order to do that, that's why I kind of time shift the animation here to make it not time dependent. I'm going to put like a rest position stuff. So would need to reset the simulation. And here, instead of the position, we're going to look up for the rest. And we're going to add it here. Alright, yeah. So that's alright. And basically also what we want to do is we want to have like the electrical arcs kind of pretty flat first, and then evolving the more they go like in age. So in order to do that, I'm going to import as well the age. I'm going to import the life, and I'm going to put a divide. To fit. And I'm going to add it in the multiply stuff, and maybe 0.3. So basically, especially like now, when it's getting static, you can see that the stuff are actually like pointing a bit outward, which I feel is giving this cool kind of energy vibe, because although if I remove it, you can see it's like it's pretty static, right? Whereas with this, you can see that the lightning is kind of like evolving even more. If I put it to 0, maybe it's, yeah, alright, maybe something in the middle. But yeah, it's pretty cool. Also, I'd like to maybe avoid having this much lighting in the same place. Like you can see, we have the same noise patterns, and that's because basically there are the source points are like pretty near. So that actually does make sense. But if I put back to P is a bit better. I'm going to keep it to P, but I'm also going to change the offset. So I'm going to bind the name, just string. Alright. I'm going to do random. What's that? Random. Alright, so now I'm going to create a random number for the name. So I'm going to put an integer, call it rand as hash name, and I'm going to rand that as well. So it's going to be a float. Or no, let's keep it integer. And we're going to put this in the offsets. So if we visualize the rand, it's like really big numbers. Alright, so now we have this. We're going to save our particles to disk. So first we're going to delete everything that we don't need. So it's everything but the name, but the ID, but the age, but the life, but the velocity, and I think that should be it. Then I'm going to put a file cache. I'm going to call that car electricity pop sim. Save that to disk. Oh yeah, we also need the source prim and source prim UV for the attribute interpolate to work. Yeah, so that's cool. Now we got our noise motion over there. Cool, and now we're going to give it a base color. So let's put like a blue, and let's put also some values in the red. It's pretty important so that it can basically by multiplying the color value, this we can make the colors go a bit more white. So like by putting a bit of value on all the component, on the red, the green, and the blue, it can create some cool stuff. Especially like, for example, if you multiply the CD dot 10, you can see like we can really get that vibrant color. And if we don't put like a bit of data on the red, for example, it's just going to appear like overly saturated, and here it looks like hot. So that's cool. So color over age, call that multiplier, and we're going to call to multiply the C as well times age divided by life. And so we're going to negate that so that it kind of appears strong and then fade out. Alright, that's kind of what we want. Mine still a bit more resolution. Yeah, it's a bit low res. Alright, pretty cool. So that's it, and now we're going to multiply the color along the curve view. Okay, cool. So now we got this. We're going to noise a bit the color. So I'm going to put an attribute VOP. I'm going to type down noise CD. And I'm going to noise it according to the curve view. I'm going to take the CD, put it in the first input of the multiply, the curve view in the second one, and put it back in CD. Alright, so now we basically can see that it only applied kind of a ramp. What we want here is a noise, so the noise is going to drive the position. Alright, create input parameter, and by increasing the frequency you can see we'll create some detail in those arcs. Cool. And I'm just going to remap this. Just so you have a bit more detail, basically. Okay, that's cool. I'm going pretty quickly here because it's not like a tutorial on it's not a tutorial on electric arcs, so I'm just going to do it pretty quickly. And now here we're going to create the P scale. So the P scale, I'm going to create a float. P scale equals CHF base P scale. Alright, so let's start with 0.1, and then we're going to multiply this by ramp. So like let's ramp P scale and rand ID. And now we're going to store the P scale as well in an attribute. Alright, so now if I do a poly wire and I just put add P scale in the wire radius, you can see it's definitely too long. So the base P scale is too big. That looks a bit better. And basically what we want to do here is we want like to have maybe a few of them that are bigger than others, but they would be mostly pretty small. So I'm going to remap that as well. Feed 0, 1, and here I'm going to do min multiplier. And then 1. So basically this is like the smallest it can get multiplied by. So I'd say the base is a bit big. Yeah, like this, alright. Okay, so now we got like a cool variation in terms of width. Usually what you can do as well, you can put some different noises as well. Usually people tend to do like a low frequency, a mid frequency, and a high frequency noise. For me, like here with the distance to camera, it's good enough, really. Alright, cool. So we got this. What else? And then just like last thing I'm going to do is I'm going to kill the velocity by just like overriding it. That way we're sure that we won't have any motion blur or deformation blur from those arcs. So I'm going to do set fail 0. That's what I usually do for rendering those kind of stuff. And then yeah, out. Then we're pretty good. Let's try it out now, and let's create another Arnold render. We can remove every light here, and I'm going to just call that car electricity. I'm going to duplicate this like one of those. Just drag and drop this. Alright. And this is the object that I want to render. I'm going to remove every matte. And I'm going to create a shader. So like here in shaders, I'm going to create a new one. Electrical arcs. Alright. This is going to be a flat shader. I'm just going to call CD. And I'm going to assign it here. Alright. And oh, it just crashed. Alright, so I'm going to restart Houdini. Alright, so now we're back. And yeah, just reassign this. Let's try car electricity. What do we have? Alright, so we have like the electricity is working pretty well. That's cool. For this kind of distance, it should be really alright. Like, we don't have to overwork this one. So let's consider this one done. And so now there's like another one I'd like to add. It's basically, so it's kind of charging some stuff up, and basically some electricity are going to be inside those guys as well. So we can do like some cool backlighting inside, and create some nice details around. So yeah, let's try it out. So this one, I'm going to call it, I don't know, like impact electricity. And yeah, I'm going to take basically the beginning of the setup, the same as the breeze, or the same maybe more as this smoke. Yeah, smoke is good. So now basically I have, yeah, the inside surfaces. I have a scatter, and I have like the scatter being animated, and the activated points. Alright, yeah, that would work. And the activation solver that would calculate the activation frame. Yeah, that's pretty cool. So now I'm basically there we go. Fucking. Sometimes Dropbox are a bit annoying inside Houdini, so I'm going to create a new attribute triangle, and I'm just going to do like a keep amount here, so that I don't have to like recalculate the activation solver every time. I can just like dial those up where I go. So I'm just going to remove some by a random threshold, and you know this one, num. Did we have the ID attribute actually? No, so like we're going to create it. Here. Alright, so you can see here, we're like, let's say for now, let's keep like 10%. And now we're going to keep our age fade of stuff that we had. So it's only keeping the activated one, and also number of frames going to be 1 to just keep the sourcing ones. Alright, that's cool. Okay, fine by me. So now I'm going to create a pop network as well. And basically the rest we can just copy and paste what we had from the character electricity. So this, and the rest. Of course I need to rename the file cache, so I'm going to just change the name to impact electricity popsim. Nice. Age fade off, we're good. Alright, so let's see what we have out of the back. So we have those guys, so it's going to create some arcs. So it is doing something, right? Alright, so now let's check it out with the actual rigid bodies in place. Come on. I'm just going to visualize it with the lower res geometry. Basically what I'm going to do as well, I'm going to create a take called an HQ take, and basically I'm going to include in that take the switch to be 0, going back to main, and also on the out, basically what I'm going to do is the main RBD is going to be rendered with HQ. That way, you know, like it will always switch to the high res geometry over there, and I can just, like in the viewport, I can just work with the mid res stuff. Cool. So yeah, let's see how it looks. Yeah, I guess it's looking alright. Yeah, think it's alright. We can do few things. We can try to call the main rigid bodies, and we can try to make them snap on each frame. Let's try that. Pop angle. In the inputs, I'm going to do inputs 2 is going to be the second context geometry. I'm going to do P equals mean pass 1 P. So that way, like each frame is going to snap to the simulation of like the stones. Yeah, maybe it's a bit better. Cool. Well, I guess that's it. Then we're going to save this. All right. Looks like I don't know why it seems that this file cache is broken. Then all right, it came back. Save to disk. We're good. Alright, and that's it. And we have our electrical arcs. So that's the good news. Going to create another layer as well. Impact electricity. And we're going to keep the same shader as the other one. Impact X3 RDR. Drag and drop this. Alright, impact electricity. I don't render with the old apps because it's going to be pretty easily done in deep. So we should be good. Hopefully. Maybe the main thing I would say here would be to change the noise to also something a bit more interesting here. But like as it's like mainly underneath, I don't think you will see that much. So we should be good. All right, and that's it then. I think maybe the last thing that we can do is we can isolate. We're going to create some light because for now we are only rendering the emissive part separately. But what we want to do as well is we want those emissive parts to emit light. And in order to do that, in Arnold, I really like to use what we called mesh lights. So I'm going to create an Arnold light. Here I'm going to call that impact electricity. I'm going to light, change it to mesh, remove normalize, set the bands to 10 maybe, that's good. And in fill to light, I'm going to put it light decay in the light filter, and I'm going to put like a far attenuation to between. So like the attenuation is basically going to do like after between 2 meters and 3 meters. we're going to ramp off the intensity of the light. So I would say like between 2 and 3 and 5, so that we don't have like, you know, really small rebounds of light really far away. That's like better for sampling. And also I'm just not going to just like drag and drop this, the electricity stuff. I'm going actually to create a mesh. So for example here, what I will do is I will multiply the P scale by 3. Alright, and I'm going to polywire here, so like the same way. Alright. And yeah, I'm just going to duplicate this. I'm going to create another out mesh. Alright. And basically now, in all our lights, I'm just going to exclude all the ones that are with this mesh light name, and I'm just going to in the mine RBT, I'm just going to force the light on the mesh light stuff. Let's see if that works fine. Oh yeah, and also I'm just switching to have like the actual mesh. And we can also just before we can do like an attribute delete to delete everything but the velocity, but the P scale, and but the color. So that way we don't have, we're not messing up with like extra attribute that we don't need. And main RBD mesh line. Alright, now let's try to increase the exposure by quite a lot. Let's try 10. Is it working? Oh yeah, no, it's not working. Also, we need to put the mesh that is being created inside the drop. So that's like something that is only used on Arnold, and it's a bit weird before on the first time. So like what I can do here, I'm going to, this is only generating to, this is not something that we want to render, this is just something that would illuminate light from. So I'm going to, the visibility, I'm going to remove everything. And I'm going to put it in Force Phantom. I'm just going to restart the render. Alright, we got something. Okay, that's cool. So we got our light. The problem is it's a bit too simple. Like it's just like a white color. Let's try to, maybe if we reduce it. Yeah, it's still just like a white color. So like what I'd like to do is I'd like to illuminate from the color I gave as an attribute. So I create like a color shader over there, and Yeah, so like it's sending me to the same place as before. It's basically, you know, like kind of a shot net inside the light, and I'm just going to do user data as RGB, put CD, and I'm going to drag and drop this in the color. All right, and now you can see we have like some cool color variation that we didn't have before. So it's good news. So like I think here we can see like the attenuation. I think we can be a little bit more extreme than that to avoid sampling when it's far away. Let's put 2.5. All right, that's cool. And then we can do the same for going to duplicate this. I'm just going to call it car. And yeah, just like we're going to keep the last spot that we created and put it on the other as well. Car electricity mesh. And we're going also to put it in the first light, so that we also, like on the first frame, we'll also render the electricity. Try to have a look at one of the first frames that we have. 1033 is a good one. Alright, so yeah, now we have like some light interaction from it. So it's cool. We render this separately so that if we want to do like just some like difference, just like a test on the mesh light, or like if we want to change the arc, we don't have to resample the rest. That's pretty common to do this, and so like we can also control the amount more easily in comp. All right, so we have those 3 new electrical elements, and we have also the shockwave. We have like the new stuff about the debris, so like we had more debris, the particles smaller and everything. So I guess we can just. The smoke was okay. Well, we're going to re-render the main read bodies with the higher res stuff. The shockwave, did we try the shockwave actually? Alright, yeah. So the shockwave is working as well. It's a bit low res, so we might want to increase the resolution as well a bit. But yeah, all in all, it's pretty cool. Yeah, let's render those. Let's render those, and then we'll see what we have. Alright guys, welcome back. So this is what we have. I just updated the render layers that were in the comp. So we can see now we have more debris and more particles as well, smaller points. And now we're going to add the other layers that we've been doing last time. So mainly the electricity and the shockwave. So yeah, let's take the deep read. Let's plug the shockwave. Alright, we do see something over there. Let's try to deep merge it. And let's color correct it as well. Alright, cool. So now we have the shockwave here. Cool, and then let's add the electricity. There we have. So for all the emissive renders, I'm actually going to do like a slightly different workflow. I'm going to show you guys, for example, the impact electricity. Alright, so we have this. What I'm going to do is I'm basically going to merge I'm going to do like a connection after the debris, let's say. I'm going to create a no up, so it's basically just like a null in Houdini. I'm going to hide the input. And let's put this as old out. That way basically we can see the lightning, but they are merged with everything else. Cool, and that way we can add them at the very end of the stream. So yeah, we need to do like a dip to image as well. Let's do that on the side. Alright, here we go. Alright, cool. So we just added those here. Why do I want to do it that way? It's because we're going to play with some glows as well. So what I like to do basically is I like to set the glow to effect only. So that we only have what's like the blurred version and not the blurred version plus the original. And we're going to merge the two in plus. And I'm going to create different glow that I'm going to merge all together. So the first one, let's put something pretty small in size. And the other one, let's try to keep it 15, and then we'll put like another one. Basically what I like to do is one small, one medium, and one big. The other one we can put like 80. You can maybe increase the brightness as well. Alright, let's see how it looks. Alright, I think we can really increase the the small one to have something a bit more intense. Let's try to increase everything, even the medium one we can increase it. And the big one, yeah, it's too much. 10, it's looking alright. Alright, and also before going any further, I'm going to do here a deep recolor. And I'm going to copy and paste basically this, but as a standard read. So like not in deep. I'm going to put the color over here. And same, just as standard read, I'm going to look up for our mesh light renders. So like this. And that way I'll be able to plus everything here. And we should be able to see all the stream, alright, like this. So we really have the light interactions here. It's not totally faked with some glows. Alright, so it's looking pretty good. And like we can maybe we can blur it. You can use some denoise as well. Yeah, it's some like I think the best would be to denoise this pass, or like to render it properly. Also, I might just do a bit of color correction. Maybe reduce a bit the gamma. Well, actually, by default, it's doing alright. You have several denoiser. The one I like is called Reduce Noise. Do I have it? Oh shit. Okay, I don't have it installed, but there's like some good denoiser on Nuke. I think that does the trick just for now. So we have the lightings. I feel like we can maybe increase a bit. Let's put a color correct, not on the glow, just on the lightning itself. Try it to have something a bit more defined. I feel like we can also change. We can change either the resolution, and maybe like on the next render we can do something a bit more high frequency. I think that'd be like a nice touch to it. Yeah, I think we really need that because it's way too simple. Cool, that shouldn't be too long. I don't even think we need to re-render the lightning, the light interaction pass. Just this thing would be enough, just to break a bit those really straight shapes. That's cool. We have the shockwave, and also we might just want to add the other electricity as well. We can combine those. Check on the first frame how it looks. Yeah, it might be a bit too much. Yeah, even like way too much. So let's basically we can duplicate this and we'll adjust the glow's value. Going to duplicate this node up, connect it here. And we're going to reduce the noise, well, the glow amount quite a lot. Yeah, especially the big one. Alright, yeah, that's way better already. Alright, cool. So let's try to render this pre-comp and see how it looks. What else do we have here? Is just at the end, it's just particles and debris. We can also render the light interaction on the debris as well, and that can help us to have a bit some few rim lights here and there. But I think the main effect is happening inside this big thing, so we should be good. Yeah, let's render this, and maybe we can talk about it on what we want to change. All right, cool. All right, so this is what we have, and with the extra layers, the electricity, and the tweaks we did on the amount of debris and the affected particles. So all in all, it's looking pretty good. It's like the main thing, the main problem now, I think it's with the lightnings, especially over there. So we're going to fix that. Basically, it's like way too straight, and it's also like, yeah, it's a bit feels like it's popping a bit, and it's not like really organic, not really organic motion. And we're going to also fix a bit here. It's not really it looked better in the viewport than it actually does look in the comp. So yeah, let's do some tests on this. So how did I comp this? Basically was is pretty simple. On the main rigid body, I put down a deep recolor, and I merged basically the beauty and just the mesh light in plus, and then I just recopied the alpha, and then I can like easily put some color correct to just like control the amount of lights in comp that I want from behind. Here we also have the shockwave, so it's just like I just put it here directly in deep with the rest. And also, yeah, what I did here is basically after the breeze, I put just like kind of a dot, and I blink that as a node up, and I basically merge the lightning with this as old out. So that way it's going basically to create those like the matte on the object. So you only see basically the lightning that are either above or between the rocks. And then I just put like a deep to image, put several glows. What I do, I like to work with some glows that are just in effect only. We have like a small glow, a medium glow, and a big glow, all added in plus. And then I just add it on the very bottom of the stream. And I do the same thing for the electricity on the characters. So I can like easily control the amount of glow that I want. So in terms of comp, we're like pretty good. I would say it's more like now to make the electric arcs more organic. So that's what we're going to be focused on. All right. So the first thing I'm going to tweak is the lightnings on the impact. So we do have those points, right? That's pretty cool. And yeah, we connect those by name, and that was like actually the wrong approach. So what I'm going to do is I'm going to offset them along the velocity vector. So I'm going to put an attribute triangle, say P plus equals V time threshold. So it's going to be our multiplier, and we're going to add a bit of randomness. So like the arcs are not all the same length. And I'm also going to multiply this by the time increment. So for us, it's we're doing 24 frames a second, so it's 1 divided by 24. And here we can multiply the threshold. All right, why is it not working? Alright, here I'm going to keep the generated velocities. Alright. Okay, cool. So now we do have some velocity. Let's save that to disk. And now we can see that what we do here is working. We are moving stuff alongside the velocity. and you can see they're not moving the same amount. So thanks to the round ID here. All right. Just going to call that offset along val. Going to merge those two. And in the add, instead of connect them by name, I'm going to connect them by ID. So that's cool. And we have this. What we might want to do now is actually we're going to make them on the other side. So like let's just negate the time increment. So that's pushing actually downward, outwards. And last thing is that we're going to put array node, not here, but actually on the point of set it. We're going to put array on domain RBD as minimum distance, just to snap basically all the points to the geo. So that way we have those kind of stuff. All right, now it looks way more organic. We're going to increase it a bit. Yeah, let's go with 8. I think that's all right. And now, yeah, we have like those noise. Let's put the geometry as well. It looks way more organic. So it should be looking way better now. And that is done. And also, yes, so about this here. Let's reduce the frequency to have like a more bigger noise actually. So like this was on the color, so we can keep that. And the noise here, we can maybe increase the amount of noise that we're putting. Something that might not be helping, maybe we can just reduce also the number of arcs to just 1. Cool, let's hide the mesh light in the viewports. Okay, yeah, so with more noise, yeah, that looks way better. And with like also less electrical arcs here in this example. I don't want to overcomplicate the electrical arc setup. It's not about the electricity, it's just like a small bonus that we can add just to help a bit the shot. Cool, and that was nice. What else? And also maybe at the very end, maybe like we should make the the particles dissipate a bit faster, because this looks a bit too magical and not really realistic. I kind of like it in a way, but we can always fade this out in comp, so maybe that's what we're going to do. Because I like this, this spot is pretty cool. Then at the end it becomes a bit distracting, but like even with just like a grade at the end, can grade a bit the alpha, and yeah. Cool, so let's not change this, and we are just going to re-render, so the emissive parts and the emissive electrical arcs and the lights. So it's pretty useful to have this the lights rendered separately. And yeah. Alright, so this is what we have now. I think it's way better now for the electricity effect. And I tweaked a bit the color as well in comp to make it less cyan and more blue-purple. Kind of soften as well the luminance of the lightning, so it's I just basically balance the overall effect. Kind of keyframe as well the glows, so it's get brighter at the momentum of the impact, and then fades off a bit more. What I don't really like yet is the electricity on the character. I feel it's not working yet. I think it's too long. It should maybe flow a bit more along his body parts, like along his arms, along his legs. So maybe we can try to fix it. And other than that, I think the shockwave is helping quite a lot. And what else can we do? We're going to fade off those particles in comp at the end, so it feels less magical. Also, maybe what I feel is maybe a bit what can be worked on as well would be the to break those clean edges up front. So maybe we can source a bit more debris. Or we can, you know, like reduce the threshold of the sourcing of the debris, so we start sourcing earlier, and then other than that, I think we're in a good spot. Yeah, let's do those tweaks, and then let's call it a day. I think we're like in a good spot. Alright, so let's try something else for the electricity. What I'm going to do is first I'm going to reduce the scale normal in the visualizers. So I press D on the viewport, and I'm going to guide and reduce the scale normal so that we can see basically to make the vectors a bit smaller in the visualizer. We're going to play with that. So after a time shift, I'm just going to put a polyframe, and I'm going to basically remove the first one, normal name, and I'm going to put N in the tangent. And I'm going to change the style to either texture UV or texture UV gradients. I think texture UV is looking good. Yeah, that's cool. Let's do this. So now also instead of one, we're basically just going to of like creating 2 points, and we're going to create just 1 point. So we got this, and basically I'm going to put that before the scatter, alright. And just remove the add. Cool. So now I do that. I'm going to reset. Nice. So what I'm going to do now is I'm going to create some velocity. So basically the vel v equals m. And each frame, I'm going to create a pop wrangle inside. P equal mean pass 1 at P. In the inputs, I'm going to put input 2 as second context geometry. And I'm going to relink the geo. So I'm going to re-snap it each frame. And that's it. Alright, cool. Now if I do, then the attribute interpolate will basically rematch that to the current place. So now we should be able to see some of those point traveling. And now I'm going to do the same thing that I did for the impact electricity. I'm going to offset the long veil and re-snap that. I'm going to re-snap it to the moving ones though. The moving geometry. Alright. So now we have stuff moving alongside along the body. I think it's going to look better, yeah. Yeah, it looks better. It's basically less. We got less electrical arcs. Yeah, it's good. Let's just maybe work a bit on the amount of the noise. Just going to check. So it is a 3D noise. Just going to increase a bit the frequency. And reduce a bit the amplitude. Going to increase the resolution as well. See with the colors how that look. Maybe we can increase a bit the amplitude as well. Alright, that looks better for me. I'm going maybe we can put a bit more electricity, so let's put 2 instead of 1. Alright, so now it is getting a bit crazier. But maybe we can compensate that with the amount of noise that we're putting in. Oh yeah, the threshold just should be 1, not 8. Where are the points? They're over there. Oh yeah, now we just need to remove this line, the num. Should be just pt num and on pt num divided by 2. Alright, so it is definitely less long arcs, so that's fine by me. Maybe we can increase it a bit. 8. We can increase the speed as well. We can do 5. Alright, so let's see in full screen how that looks. Alright, yes, I feel it's working much better now. Yeah, so that's cool. Let's put a flip book. Yeah. Yeah, that's way better. Alright, so now we got this part figured out. So we just need to re-render this, basically. What else did we have? That was the main point, right? And then there's just like a comp tweak here that we can do right now. So basically, I think it's from frame 1105. Can start to do color corrects, because I like this frame quite a lot, but it's really at the end. So I'm just going to put a deep color correct, set the key to 1, and then on the last frame let's try by increase it, because by increase it will blend maybe a bit more with the rest, like this. Yeah. So it is blending more, and we still have this extra detail. So I feel maybe that could be an option. Let's try to put up the gamma. So no, it's way too much now. Maybe if we put 3, what do we have? It's too much. 2 is good. I'd say 2 is good. Alright, cool. Oh yeah, and there was also like the debris. So what we're going to do for the debris is basically so yeah, basically what you can see, I think the problem is over there. Those ones should be already activated from this part here. So what we can do is actually tweak the distance multiplier to maybe 1.2. And that way, you'll see if I go back to 1.5 on the side. You can see that now we're going to activate stuff sooner, so it should be better. Hopefully. But about the overall amount, I think it's good. Otherwise, what we can do is actually do another one. Called small debris. I'm just going to call that debris small RBD simulation. That's cool. And here, basically, we're going to increase by 3 the amount of points that we scatter on the inside surfaces. That's cool. And here we're just going to increase this distance that we talked about, and maybe the min distance can be a bit smaller as well. All right. So that's cool. And let's run this. And here, all right, so we're just skipping to 1 frame, so that's good. And so we're going to reduce a bit the P scale, 0.15. Yeah, and basically we're going to render this as an extra layer just to have maybe a bit more really small debris on the edge. But actually just to keep this level of debris here. So yeah, kind of like an in-between layer basically between the particles and the debris. So yeah, let's try to run that. Alright guys, so now I just rendered just a test frame on the small debris layer that we talked about. So I just wanted to see to show you guys the difference. I think it helps quite a lot basically to sail the transition area basically. I think it helps quite a lot. It was, I think, a good idea to split this up and just redo like a pass with smaller debris, because if we source the bigger ones, I think we could have seen the trick that we're actually sourcing. So sometimes you have some popping issues, but like by sourcing the very small ones, I think it gave us some nice details. So now I'm going to render the whole frame range on this thing. Yeah, cool. Alright, so this is it. This is the final result that we have. With the contact sheet here. So yeah, we got this new layer, the small debris. I tweaked a bit the electricity, like giving a bit more resolution in the resample with a high frequency noise on top. But other than that, it's pretty much it. Yeah, I just added a cam shake in Nuke to see a bit more the impact. But yeah, that's it. Well done, guys, for following this tutorial till the end. And see you next time.